Today you will be learning about metallurgy of aluminium. First, aluminium has its ore called bauxite with the formula Al2O3 2H2O. This bauxite contains impurities like silica, iron oxide and titanium dioxide. That has to be concentrated. Concentration method is known as leaching. Leaching means chemical washing, wherein we are taking the impure ore and heating it in the presence of a suitable reagent to get the ore particles alone dissolved in it and it gets separated. Here we are doing the leaching by the method called BAEYER's process. After leaching, we get the pure alumina. This pure alumina is further undergoing reduction in the presence of electricity. So, electrolytic refining is done. Which results in pure aluminium. So, we shall discuss what is the leaching process that is happening here and what is the electrolytic reduction. We shall now see leaching of alumina. Alumina has the formula Al2O3 2H2O. It also contains the impurities like silica, iron oxide and titanium dioxide. To remove these impurities, we have to subject it to leaching. Here, alumina is treated with sodium hydroxide solution at a temperature around 473 to 523 Kelvin at 35 to 36 bar pressure. When sodium aluminate is formed with the formula NaAlOH 4 times. Here you find that it forms the product 2NaAlOH 4 times. Further, this sodium aluminate, which is basic in nature, reacts with an acidic oxide carbon dioxide to liberate the hydrated aluminum along with sodium bicarbonate. Further, the hydrated alumina is subjected to digestion at a very high temperature around 1470 Kelvin when pure alumina is separated from water. You know that aluminum is a very reactive metal. So, to get back the pure aluminum from alumina, it is difficult to treat it with a reducing agent. So, we have to resort to a better method using drastic condition that is happening in the presence of electricity. So, electrolytic reduction is favored. Final step involved in metallurgy of aluminium is electrolytic refining. This is otherwise known as Hall-Héroult process, wherein we are choosing an electrolytic cell which consists of an iron tank lined with carbon as a cathode, whereas graphite electrodes which are connected parallel to each other form the anode, and we are choosing a liquid, that is the electrolyte chosen is molten alumina along with a mixture of sodium aluminate. The electrolyte used is molten alumina with cryolite which is Na3AlF6. The purpose of adding Na3AlF6 is to reduce the melting point of alumina, which is around 2500 Kelvin, to around 1700 Kelvin. It also helps in increasing the conductivity of the molten alumina. Now, the various chemical reactions happening during electrolytic reduction are: alumina on passing electricity will split into 2Al3 plus and 3O2 minus. Now, at the anode, we have carbon, that is graphite. Carbon will take up O2 minus and convert it into carbon monoxide or carbon dioxide, as the case may be, resulting in liberation of electrons. So this part becomes the oxidation part. Whereas at the cathode, you find the positive ions, aluminium ions, migrate there and it receives 3 electrons from there, resulting in aluminium. So the overall reaction will be 2Al2O3 plus 3 carbon, giving 4Al plus 3 carbon dioxide. So finally, what we get in the tank is aluminium, which is tapped out. So this explains the metallurgy of